All right, so this goes back to the whole idea about some theories about science, which this first unit is kind of like three sort of distinct mini units inside there. So this last day today is all about sort of the theory of science and that kind of thing. And one of the things that I'm supposed to teach you about is the law of parsimony. Okay, so it's right there. It's a little story I'm going to read to you. Kind of an interesting little thing. It's a true story. And it goes to the sort of the foundations, the idea of what is science. So let's have a quick read here. Not all explanations for a knowledge claim are created equal. Some explanations involve more details and make more assumptions than the others. Assume you were confronted by two explanations for the same phenomenon. Both explanations seem equally plausible. What does that word mean? Plausible. Possible or likely. Which one would you select? The one that involved numerous assumptions and details, in other words, the complicated one, or the one that involved fewer assumptions and details? Which one? The really complicated explanation or the pretty simple one? Obvious. Come on.
Simple one.
Simple one, thank you, Lane. Well done. Lane's a brave guy. If common sense tells you to select the explanation that makes the fewest assumptions, remember assumptions also require explanations, then you already have a good understanding of the law of parsimony. Lane can check it off. He understands the law of parsimony. There you are. Thank you, Aaron. 9:10. Sorry. From yesterday. A package. Okay. So Leighton already understands the law of parsimony because he knows that the simplest one is quite likely the correct one. Here's an old and excellent example of the law of parsimony. In the early 1900s, Mr. Wilhelm von Osten, a retired mathematics teacher with nothing better to do, owned a remarkable horse named Clever Hans. Hans became world famous because he apparently could solve mathematical problems that involved decimals, fractions, tell time, read, and among other remarkable abilities. This horse was a genius. For example, someone, his trainer as well as other strangers, might ask Hans what 7 divided by 4 equals. Hans would tap the answer out with his hoof and receive a treat when he was correct, which is well over 90% of the time better than the average grade 9 student. Little joke there, Mark. A committee that included the noted German psychologist Karl Stumpf was appointed by the German government to study the phenomenal horse and prove his so-called abilities were nothing but a hoax. The committee completed their task and reported that although they were unable to prove that Hans was receiving intentional cues, they remained unconvinced that he was able to solve such mathematical problems and complete the remarkable feats by using his cognitive process. So in other words, they couldn't figure out how he was doing it, but they were pretty sure the horse wasn't that smart. What do you think? Was this a smart horse? Or do you think there's something going on here? Stumpf's assistant, Oskar Funks, decided to continue investigating the phenomenal horse. Funks conducted several experiments and concluded that when Hans could see the person asking the questions, then he was able to supply the correct answer. So he built like a wall, and if the person stood behind the wall and asked the horse questions, well, he couldn't answer the question. If Hans could not see the person, his performance fell to near zero levels. He had no idea what was going on, right? So only when he could see the person asking the question. But it didn't matter which person was asking the question. So it wasn't like a scam where, like, the trainer was giving him, like, this kind of thing to stop, right? The horse was doing something. It didn't matter who was asking the question. Funks was faced with 2 alternative explanations for the horse's abilities. One, Hans understood the questions and was able to use cognitive process. In other words, this was a genius horse. But only when he was able to see the question or solve the problems, right? He was only a genius when he could see the person asking the question. Or 2, the person asking the question was somehow inadvertently cueing the horse when to stop tapping at the appropriate moment. Which one of those 2 do you think is most likely correct? Number 1 or number 2? Number 2. Correct, Josh. Applying the law of parsimony, Funks chose the latter explanation and persisted in his investigations. He finally determined that almost everyone who asked questions of Hans made a minute upward movement of their head when the correct answer was reached. So that he would ask the horse a question, and just as you got to the answer, the person's head would go like this, and the horse read the person's body language, knew when to stop, got a sugar cue or his apple or whatever they were giving the horse. Kind of still a pretty smart horse, right? Do students do this all the time? Sam, you and I did it just a couple days ago, I remember, right? I think you asked me a question, and then I started answering, and you decided by the tone in my voice that I was telling you that you were wrong, right? Students do this all the time. Humans do it all the time, right? We read each other's body language. Some are better at it than others. This is a genius horse at reading body language. Okay? So he finally determined that almost everyone who asked questions of hands made a minute upward movement of the head when the correct answer was reached. The horse used this cue to stop tapping and received his treat. This was an instance of positive reinforcement. If you apply the law of parsimony as you evaluate knowledge claims, you are well on your way to becoming a good psychological consumer. Some additional points to consider as you evaluate knowledge claims to cover the next section. Don't worry about that. Okay? So, if you had to summarize the law of parsimony, write it down in like one sentence at the bottom there with a space, what would you write? The horse was cheating. Oh, you didn't get sheep? There's no thing yesterday factor check. Yes, that big factor check. Yeah, he was. Yeah, here. There you go. So, if you were to write down one sentence explanation of the law of parsimony, what would you write? Am I going to have to write it for you? Yeah? Joel, what would you write? You get your hand up or you just write it?
No, the simpler two plausible theories is the one you will pick.
Would it have to be two?
Well, that's
Yeah. Right. Okay, so given two explanations, or given multiple explanations, right? Given multiple explanations, the simplest is likely the correct one? Likely correct? Yeah. In other words, keep it simple, right? The most obvious. You've heard the expression where there's smoke, there's fire. Right? There's talk about going with your gut, and there's also using your head, right? Sometimes going with your gut isn't always the best, right? Common sense isn't always the correct answer. I've got an example of that right away. But the law of parsimony says that given two explanations, the simplest, given multiple explanations, man, my writing's bad, the simplest is likely the correct. I learned to write in Australia, so that's what I blame it on. Yeah. And I only have 4 months of grade 1, too late.
Are we in Australia?
I went on, it went away. I went on family exchange. My dad was a teacher too. We went on teacher exchange, and I was in grade 1. And when I got down there, because they have like different years, you know, like their summers, our winter, that kind of thing, right? So when I got down there, I had 4 months of grade 1. We went in January, and they tested me, and based on my age, they put me in grade 2. So I spent a whole year of grade 2 down there, and then when I came back, I finished grade 2 here. So I only have 4 months of grade 1. I'm a little weak on my grade 1. That's a true story. It's not made up. Now that's probably the simplest explanation of it, but when I say the simplest, what do I really mean? With the fewest assumptions and explanations. Right? Policemen use this all the time, right? When they're trying to figure something out. It's usually the one that's the simplest. Another real good example of this is the Copernican and the solar system model, right? Originally they thought the Earth was at the center. How come they thought the Earth was at the center? Because we're there, right? You look up, you see, oh, things are moving around us, right? Just makes sense, kind of. But then when you try to sort of plot the planets out and all the stars, it didn't make a lot of sense. Copernicus put the sun at the center, and suddenly everything was a whole lot simpler. Therefore, most likely correct. Now, is going with your gut always the best? Let's look at the next one here. Next page. Your first thought is not always the right thought. This is called Bayesian thinking. Two examples from World War II. The first of all is the statistician Abraham Wald, who was asked to determine where to add a limited amount of armor plating on bombers to protect them against anti-aircraft fire. So they had these planes, bombers. They were being shot down. They had a limited amount of armor, so they wanted to know where's the best place to put the armor. When a plane returned from a mission, the Air Force would record the location of all the bullet holes, so there was plenty of data. Furthermore, there were clearly more hits in some parts of the plane than others, so the answer was obvious. Put the armor plating only where there was a high density of bullet holes, right? Completely wrong. Why? Planes went out, the planes that come back were analyzed, they found certain spots where there was always bullet holes, right? Put the armor plating there, right? Those are the planes that made it back, right? You are, Sean. Did those planes make it back even though they had bullet holes in those spots? They did. So which planes didn't make it back, Sean? The ones that got shot down in the other spots. It was the planes that came back with the holes in them that made it back. Those spots there's nothing important behind them, right? Put the armor where those holes weren't. Is that common sense? It is when you explain it, right? But it's not the first time. Here's another one. Second story relates to placing anti-aircraft guns and gunnery crews aboard merchant ships to protect them against enemy bombers. Since both the weapons and crew training were in scarce supply, a handful of vessels were equipped to test the idea for several weeks. At the end of the trial period, the gunnery crews were asked how many planes they shot down, and the answer, unfortunately, was none. So the entire plan was about to be scrapped because they didn't shoot down any planes. When someone thought to ask a different question, which was, harder question here. Go ahead and explain the story a little bit more. Okay, so they had anti-aircraft guns and gunnery crews aboard merchant ships to protect them against enemy bombers. So the bombers, the German bombers were bombing regular merchant ships, not army ships, merchant ships, to protect them against the bombs. Since both the weapons and crew training were in scarce supply, there was only a handful of ships were equipped to test the idea for several weeks. At the end of the trial period, the crews were asked how many planes they shot down. The answer was none. Was the program a success? It was, because someone finally realized they should ask how many boats were sunk. And the answer was none. So what did the guns do on the boats? Scared away the bombers. Exactly. It's the same principle as putting up the fake security cameras. Does it stop people from robbing the convenience store? Tough to say, really, right? Because we don't have the data how much there would be, right? But that's the same idea. Okay. I'm going to leave the Monty Hall stuff for the end of the period because it's kind of fun, and we can't have too much fun in here. Okay? So, what I'd like you to do is, you've got the rest of this period till about like 5 to 10 or so. Do vector problems if you think you need extra practice. If you want to work on a study sheet for the test, do that. If you're one of those people whose lab was not in yesterday, convene your group and get it in, okay? Did I hand back the lab yesterday? I did. I realized when I was marking them that I probably didn't give you the expectations as close as I should have, okay? I expected a little more, like, yeah, I've done a better job. There's one or two groups that I'm going to offer if they want to redo, I will allow it, okay? So, those are your jobs. Use your time wisely. Get ready for this test as best you can. Yeah, yours is in the plate, right? It's right here.
Yeah, the only reason I was like, people tired.
I don't know what
Just kind of like, hey, walk with me. I'm like, oh, I'm not. This is a help with that. You go get a computer.
That whole morning phys ed, you come back. That's not good. Yeah. Sometimes, anyway. Most of the time, it's pretty good. So let's try to make most of the time even more. Yeah. Okay, Zach, this is yours, sir. Remember, everyone has to be able to create a graph for the test. So if you don't know how to do it, if someone else did it, you get in there to a computer and figure it out. Okay, so what happened on those two graphs? Okay, you need to finish them, my friend. Okay, let's get them done, like right now. Okay? Okay? Get it done.
Excuse me?
I don't know. Sound like yeah. Stupid mistakes. I'll try to implement it. I'll figure it out. Okay, so I see this and now I start Oh. There's a lot of math in here. Okay. Okay. Fair enough. So, actually, you're going to have to create a resource for folks trying to become a resource pro. It's going to be hard work. Right. Okay, get to work. Okay. Okay, Hannah, let me see here. What do you got? Yes. It took me forever to figure out what the heck was wrong with it. Like, what is wrong with it? Yeah, so, well, and actually, this is it. Upside down. Raise. These numbers, like, yeah. This is your X. This is your Y. And then, of course, this one. Okay, so here's what I'll make you a deal. Fix the graph, right? Graph, fix this. Okay? Oh, wait. What's going on there, Marty? Hey? How you submit it? Oh, the lab thing? I can give that to me like a favor. Like what? It should be like all one document though. Print it out. Print it to the science printer time. Come on in here, Mark. Let's see. Yeah, that's correct. Okay, I'm gonna delete that one. Right, so you gotta do like this. Right. You gotta do that. There you go. Okay, I want to see. I want to see the equation too, right? There you go. Y equals 5x. That's pretty much x. Well, of course, that's 1.5. I know. We just made up that. Okay. Where's this science easy number. Okay, so if the answers are wrong, then I would 90 minus your answer is the answer. You went like this, but I would have gone like that, right? So yours is, I mean, this one here, yours is 36. Mine is 24. Except yours is south 36 west, right? Yeah. And mine west 54 south. Imagine Josh is a ruler anyway. Oh my god. Why do you have catch that? Wow. Because like apparently they want gravity as okay.
I was playing video games.
What? Have you answered all the questions? Stuff. You can program that. I know. Have you answered all the questions? Or do you know? Okay. So it's not like no. Never have I ever shown you that. Ever. That's regular addition factors. They're vectors. Okay? It should be here is your resultant, right? Resultant, so resultant plus minus ball. When I say resultant, I mean vector resultant plus is tip to tail, this is minus ball. You measure that and measure the angle. Never, ever, ever do that with vectors. Have I made myself clear? Right? Sorry, I should have warned. You need a new group. Okay, so I'm kind of concerned that Wisconsin seems to be doing all the lab work.
And this is difficult. This is what you get to.
Yeah, I know. Work? 35. Okay.
Whoa, that's.
I'm gonna get yours marked and get you, what class do you have next? LA with you. Okay, I'll bring you your, okay? Hey, so Carter, are we doing some work here? You know what, like, well, I've got tomorrow scheduled for review / things, but if I see people, with all due respect, kind of looking up Pac-Man ghosts, it doesn't sort of signal to me that you're going to use tomorrow's class any better. So if you want tomorrow's class, I need to see some, you know, stuff happening right now. Right? What did I do then? What's wrong? Well, we usually have a score, that's fine. Number one browser than any other browser. Well, we could do that.